Now students, let us learn today more about carbon. Last day we were talking about the characteristics of carbon, or we can say nature of carbon compounds. We have got the idea that carbon compounds are large in number. Why it exists large in number? Due to characteristics of carbon. Due to characteristics of carbon, we can say carbon compounds have large number existence. What are those characteristics? Last day we were talking about those characteristics. Some of the characteristics like isomerism, allotropy, we will talk today. Initially we were talking about tetravalency, and we were talking also about catenation. You know those catenation and tetravalency. Tetravalency means carbon has 4 valence electrons. Due to this, carbon has tendency to form 4 single covalent bonds, or maybe 2 single bond and 1 double bond. It could be there. So this is also one of the important nature of carbon, so that carbon can form, or carbon can connect itself with many type of elements, many type of atoms. It has a special affinity with hydrogen, and a different set of group of compound hydrocarbon is there, which is made of only of carbon and hydrogen. Second thing, we have learned about catenation. We have got the idea that carbon has a special capacity to link with other carbon atoms to form long chain. This long chain could be a straight chain, or could be branched chain, and sometimes closed chain also. So this nature of carbon is also responsible for large number of organic compounds. Then two things is very important: allotropy. Carbon can exist in elemental form or in compound form, in combined state also, in free state also. In free state, it exists mainly in form of diamond and graphite, and sometimes coke, Buckminster fluorine. This property of carbon is called allotropy. So we were talking about versatile nature of carbon. The third point is allotropy. What is the meaning allotropy? Carbon can exist in different forms. Having different nature. This is known as allotropy. This is known as allotropy. For example, carbon in its elemental form can exist merely as diamond and graphite. Diamond is a non-conductor of electricity. Diamond is non-conductor of electricity. Return electricity, while graphite is a good conductor. Diamond is the hardest substance. Diamond is one of the hardest substances. One of the hardest substances. Having tetrahedral structure. One of the hardest substances. But graphite is very soft. The difference in physical properties of diamond and graphite arises because of different arrangements of carbon atoms in them. The difference in the physical properties of diamond and graphite arises because of due to different arrangements of atoms. Different arrangements of atoms of carbon. In them. Actually, if you are talking about diamond, diamond has got tetrahedral structure, and in diamond crystal, carbon atoms are powerfully bonded to one another by a network of covalent bonds. Diamond has tetrahedral structure in which carbon atoms are powerfully bonded to one another by a network of covalent bonds. By a network of strong covalent bonds. Due to this, diamond structure is very result. Due to this, diamond structure is very rigid. While structure of graphite is very different from that of diamond. While the structure of graphite is quite different from that of diamond. A graphite crystal consists of layer of carbon atoms or sheets of carbon atoms by hexagonal rings form flat hexagonal rings. Graphite has hexagonal structure. Graphite has hexagonal structure. The various layers of carbon atoms in graphite are quite far apart. In graphite, are far apart so that no covalent bonds exist between them. So that no covalent bond exists between them. They are held together by weak van der Waals force. They are joined together by weak van der Waals force. The weak van der Waals force. So graphite is soft. Because these layers can slide over one another. So due to this, graphite has different uses as lubricants and maybe for connecting in the electricity substances or whatever. And there is another allotrope Buckminster folding, where 16 carbon atoms in a molecule is joined together in the form of a sphere. But Mr. Furlin actually this was developed. The arrangement of carbon atoms in Buckminster Fullerene resembles that of football. But carbon can exist in compound form, in coal, in carbon dioxide, in petroleum products, fossil fuels, natural gas. Also, carbon can exist in combined state, as coal, petroleum, natural gas, carbonates, limestones, carbon dioxide gas, and organic compounds like carbohydrates, fats, and protein. So, as carbohydrates, fats, and proteins. Wood, cotton, wool, etc. So these are the existence of carbon in different form. Allotropy. This is known as allotropy. Another property of carbon is isomerism. Carbon compound shows isomerism. What is isomerism? Isomerism is a phenomenon in which compounds have same chemical formula, same molecular formula, but different structure formula. Different structure formula. Example: butane, C4H10 have two isomers. Normal butane, isobutane. So these are two isomers. Chemical formula, molecular formula same, C4H10, but their arrangements are different. This is a straight chain, but here one branched carbon atom. This property is known as isomerism. And this, due to isomerism, large number of carbon compounds exist. Another compounds also, pentane, hexane also shows isomerism. This special property, isomerism. Okay, students, thank you.